Hello, so welcome to the second part of the video. Now, before in part one, we implemented all the steps. We made the environment in Anaconda on our local system, and we also cloned the repository into our folder. But due to the unavailability of GPU, we couldn't go further. We couldn't implement these files because it required NVIDIA GPU or CUDA GPU. Okay, so we will go to Google Colab. Google Colab is an amazing tool to do high processing works. It provides us its GPU free access to GPUs and easy sharing, all that. Okay, so we will make a new notebook here. As you can see, the notebook is being loaded. Let's rename the Python notebook to Slow-Mo project. Okay, and second of all, we will change its runtime so that we can have the power of GPU. Okay, so saving. Now it will be allocating the respective GPU. As we can see here, these are the files workspace where we can add files to work with. Now this is where we will implement the code, Python code. Now we will implement all the steps that we did in Anaconda. Okay, so prerequisite, we have to install Pytorch 1.1, and we have to install these Python packages. Okay, the beauty of Google Colab is that many of the packages are already built in. Okay, and even if it is not built in, we can install it with pip install. Pip install basically is a Python command which install specific libraries that we intended to install. Now, just as we did in Anaconda, we will install the Pytorch 1.1. In order to do that, let's go here. While working on Google Collaboratory, we have to put the exclamation mark at the start of each command. Okay, and pip, as I told you earlier, is the Python command to install specific libraries. As you can see, the PyTorch and Torch Vision is being installed here. Or if you don't know what PyTorch is a deep learning library. Similarly, there is TensorFlow, there is OpenCV, there are many libraries for deep learning. Here it has used, this repository has used the PyTorch version. Now we are installing the PyTorch 1.1. Now as you can see, we have successfully installed PyTorch and Torch Vision. Now let's add another code cell, and what will move on to the next step. We have installed PyTorch. Now we will install these Python packages. Remember, always put the exclamation mark first and then the pip install command. Now let's run this snippet. As you can see, some requirements are already satisfied. As I told you before, Google Colab already has the vast majority of Python libraries pre-installed, and this snippet has successfully been implemented. Now, the next step was to install the required packages pip install requirements.txt. But first of all, we need to clone it. We will need to clone the whole repository onto the Google Colab. Now let's do that. Another code cell, and we will paste it here. Now what it is doing here, that it is cloning the repository into a folder called cvpr, and the cd command moves our directory onto this folder. Okay, so let's do this. Just like we did in Anaconda, the repository is being cloned into our Google Collaboratory Python notebook, and it has been cloned. Let's see where it is. Now, as you can see there, a CVPR folder has been made, and going into this folder, we can see the whole code has been cloned here. And here is the requirement.txt file. Okay, now going into the requirement.txt file, it is the same libraries that we pip installed earlier. You can see here we already installed it, so no need to run these requirements file. Okay, now coming on the second step to compile the DCMV2, okay, which is the deformable convolution network. Okay, this step can this step was left out in Anaconda because my machine wasn't powerful enough and it didn't have a GPU. Now we have the Google Colab GPU. Now we're going to implement this. Okay, now first of all we will go into the folders, codes, models, modules, and DCMV2. Let's see where that is. We have the codes here, we have the models here, and we have the modules here. Now this is the folder we need to go into, okay, to execute this make.sh shell file, and then to test the DCM model and run the Python file here. So let's go ahead and do that. Here, as we can see, it is being loaded. The current directory is being changed where the DCN folder is to execute the bash file and the Python test file. Now let's run it. As you can see, the model is being built. It's going to take a few seconds only. We can close this. I just opened it to show you where all the files are. Now as you can see, the Python script has been successfully implemented. Okay, so it has been compiled and the test script has also finished successfully. Now coming on to the next part, which is the training and testing part. So in making the neural network, we have to first of all prepare the data and split it into train and testing. Okay, training and testing. So in this case, in this repository, it has trained on a large dataset of 82 GB, which takes weeks to train a model. Okay, luckily and very effectively, this repository has also provided us with a pre-trained model, which is here because it knows that training the same code over will take a very long time. So it has provided us with a pre-trained model. Let's see where the pre-trained model is. Now we'll go to CVPR and experiments. Here is the pre-trained models, and this is the pre-trained model file, okay, which we will be using to convert a simple video into a slow motion video. Let's see how to do that. Let's add another code snippet. Mm. So another thing, in the contents folder, I have chosen a video to experiment on. Let's add this video in the Google repository. Let's add it here in the, let's say, content folder. Okay, in the content folder, here's a video that will be implemented, which we will use the model, the pre-trained model, to implement the slow motion. Now let's do that. Now here what I've done is I have changed my directory to the CVPR folder, simple, and then in the next file I have run this file. This is a Python script that converts the simple video to the slow motion video that we are trying to acquire. Okay, so let's see. First of all, on the Python, this is the Python path to the video.py file. Okay, next we are using the pre-trained model. Okay, so model, this is the path to the pre-trained model as I've shown you previously. Second of all, we will add the video path. Okay, now let's see where the video path is. Content and Beirut. Okay, the video path is already there. Now where would we like the output video to be made? And you can see there that it is the same folder. The output video will be made here. Okay, so let's implement it. Now the whole process will take several minutes depending upon the length of the video. I think the current length of the video is 3 to 4 seconds only, so it's going to take only 1 to 2 minutes. And let's see the output here. The output will be displayed in the content folder underneath this MP4 file. Similarly, you can add any video of your choice, but its format should be an MP4. Okay, so let's wait and see. So it took about 2 to 3 minutes, but the output is finally available. Now this piece of code has been implemented, and we finally have our output. Now let's see what we got. We're going to download the MP4 file, and let's see. Now as you can see, it has been slow mode efficiently by the repository code, and that's it. You can do this with any video you want, any input video you want, any MP4 video you want. It is gonna take some processing time, so I suggest you use the Google repository, Google Colab, to and use its GPUs because it's very effective. And that's it. Hope you understood the whole process. And if there is any questions, do let me know. I am here. And that's the end of the repository. And yes, that's it. Thank you for listening.